today we're going to look at the second form of statistical inference that we have for one categorical variable, which is a hypothesis test. So because we're talking about one categorical variable, our parameter of interest is one population proportion. So we're looking at a hypothesis test for that parameter. So there's a lot of vocabulary associated with hypothesis testing, and since this is the first time you see hypothesis testing, we're going to spend a fair amount of time on the vocab and what things mean and what they refer to. So in general, a hypothesis test will ask a specific question about a population parameter. And it does that by saying that one of two statements can be true, and only one of two statements can be true. The two statements that we will be using are called the null and alternative. And what you'll notice, because only one of them can be true, they're actually competing statements. So they'll be complements or opposites of one another. Now, the null hypothesis is a statement or a claim of equality. It also could be thought of as a statement of no difference or no relationship, or sometimes people refer to it as a statement of status quo. Now, I want to look at this null hypothesis and show you some options for writing a null hypothesis by using the example of Skittles and the proportion of red Skittles. So Skittles and the makers of Skittles say that they taste the rainbow, meaning that there's an equal proportion of all 5 colors. So that means that they're claiming that 20% of their bags are each of the 5 colors. So we're specifically going to be interested in the proportion of reds. So if I were to do a hypothesis test on that, there are 3 different statements I could make. So I could say for my null hypothesis, and when you write a null hypothesis, you write capital H, lowercase o, colon. Then you write the notation for the parameter you're trying to make an inference on, which here is going to be P. So one option is as a statement of equality that P is less than or equal to 0.2, which, as you know, is also saying 20%. So a second statement that I could make as a statement of equality or a possibility for a null would be that P is greater than or equal to 0.2. And again, I could similarly write 20%. Now you would never write all 3 of these, but these are the options that are available to you. And then the third statement I could write in terms of a null hypothesis or a statement of equality for my parameter is that P equals 0.2. So those are the 3 possible null hypotheses if I'm looking at the proportion of red Skittles. Now, if I wanted to look at an alternative hypothesis, remember that I said earlier a null and alternative are going to be complements of one another, so they're going to be competing statements. So that means that a null hypothesis is a claim of inequality or a difference or a relationship. And a lot of times this is what a researcher actually wants to be able to show, and so it's thought of as the research hypothesis. Now, because these are complements, that means if I were to write an alternative, so written similarly, it's capital H, but this is going to be capital H sub A, P, an alternative to what's shown up here in blue as a null. If this is less than or equal to, a complement to that would be greater than. So this is a statement of inequality, so you'd never have the equal sign in the alternative. Remember, the null hypothesis is a statement of equality, so it will always contain the equal sign. So for the purple, if I were to write the corresponding alternative for what's written as the null, I would have P less than 0.2. And then finally, for the green, its competing statement or the corresponding alternative for the null P equals 0.2 would be an alternative P does not equal 0.2. So you'll notice that these are complements, so they both cannot be true. You cannot have both equals and then also not equals. So they're complements of each other, and only one of the statements will end up being true. Now, when you do a hypothesis test, you are actually conducting it assuming that the null hypothesis is true. So we always do it assuming the null is true. Essentially, that will end up just meaning that we assume the center of our distribution is actually what this parameter is.